Improper integrals. An improper integral is one in which either the upper or lower limit of integration is infinity. Symbolically, an improper integral is one of the following forms. We can integrate f of x from a to infinity, or we can integrate from negative infinity to some number b. The integral from a to b of f of x with respect to x may also be improper if f of x is discontinuous at any point in the interval from a to b. To evaluate improper integrals, we use limits, and we'll evaluate as follows. The integral from a to infinity of f of x with respect to x can be evaluated as the limit as t approaches infinity of a to t of f of x with respect to x, and the integral from negative infinity to b can be evaluated as the limit as t approaches negative infinity of t to b of f of x with respect to x. If the limit as t approaches infinity or as t approaches negative infinity exists, then we say that the interval converges. Otherwise, it diverges. Example 1, we're asked to evaluate the integral from negative infinity to negative 1 of 3 divided by x to the 5th power with respect to x. Well, we observe that this integral is improper because the lower limit is negative infinity, and so we'll rewrite as follows. We'll rewrite as the limit as t approaches negative infinity of t to negative 1 of 3 divided by x to the 5th with respect to x. Now we'll evaluate that integral from t to negative 1. The antiderivative of 3 divided by x to the 5th is negative 3 over 4x to the 4th, and I need to evaluate that from t to negative 1. I'll evaluate my antiderivative at both my upper and lower limits and subtract. When I evaluate at negative 1, I end up with negative 3/4. When I evaluate at t, I end up with 3 divided by 4t to the 4th. Now I'll evaluate the limit as t goes to negative infinity. There's no t in the first term, so that limit is negative 3/4, and as t goes to negative infinity, the second term goes to 0, so I find that my limit is equal to negative 3/4. Therefore, the integral of negative infinity to negative 1 of 3 divided by x to the 5th with respect to x is equal to negative 3/4. If I try to evaluate this integral on my calculator, I see that it gives me a value that's very close to negative 3/4. Example 2, I want to evaluate the integral from 1 to infinity of e to the negative x with respect to x. Again, I'll observe that the integral is improper, and I'll rewrite it as follows. I'll rewrite as the limit as t approaches infinity of the integral from 1 to t of e to the negative x with respect to x. Then I'll evaluate that integral from 1 to t. The antiderivative of e to the negative x is negative e to the negative x, and I'll evaluate that from 1 to t. When I do so, I end up with negative 1 divided by e to the t plus 1 divided by e. Now I'll evaluate the limit as t approaches positive infinity. In the first term, as t gets big, the value of 1 over e to the t goes to 0. In the second term, 1 over e remains 1 over e. So I get that the integral from 1 to infinity of e to the negative x with respect to x is equal to 1 over e, and this means that my integral converges. Again, if I use the calculator to evaluate this integral, I see that it gives me a value very close to 1 divided by e. Example 3, I want to evaluate the integral from 1 to infinity of 1 divided by x with respect to x. This too is an improper integral, and I'll rewrite as the limit as t approaches infinity of 1 to t of 1 over x with respect to x. Evaluate from 1 to t. The antiderivative of 1 over x is the natural log of x, and I'll evaluate that from 1 to t. When I do so, I end up with the natural log of t minus 0. Now I'll evaluate the limit as t approaches infinity, and as t gets larger, the natural log of t gets larger also, and so that limit is infinity, which means that my integral diverges. In this last example, I'm asked to evaluate the integral from negative 1 to 1 of the natural log of the absolute value of x with respect to x. At first glance, this integral does not appear to be improper. It is, however, because the integrand is discontinuous at x equals 0. Therefore, we'll evaluate the integral as follows. We'll rewrite as the integral from negative 1 to 0 of the natural log of the opposite of x plus the integral from 0 to 1 of the natural log of x. The reason for the change in the argument of x: for negative values of x, we'll recall that the absolute value is equal to the opposite of x. And for positive values of x, the absolute value of x is just equal to x. Because both of those integrals are improper, I'll evaluate as follows. The first I'll evaluate as the limit as b approaches 0 from the left of the integral of negative 1 to b of the natural log of the opposite of x with respect to x. The second integral I'll evaluate as the limit as a approaches 0 from the right of the integral from a to 1 of the natural log of x. I'll use the calculator to evaluate each of these integrals. The first integral, I see that the calculator gives me a value very close to negative 1, and the same is true for the second one. So now my integral from negative 1 to 1 of the natural log of the absolute value of x was rewritten as the integral from negative 1 to 0 of the natural log of the opposite of x plus the integral from 0 to 1 of the natural log of x. I evaluated those improper integrals using the calculator and found that both were equal to negative 1. So negative 1 plus negative 1 is negative 2. Therefore, my integral converges to negative 2.